lesson number 96, Algebra 2, joint and combined variation, as well as more and irrational roots. Alright, so if you remember a while back when we were doing different variations, we did a direct variation, and we said that that was some letter equals k times another letter. That was direct. And then inverse was k over a. So that's direct, and inverse looked like that. Alright, as far as direct, we also looked at another possibility using ratios. Okay, and then I said that, remember, the inverse variation looks the exact same, only the second ones are flipped upside down. That was the only difference there. And you don't have to deal with a k when you're dealing with these. So anyway, that was what we were doing with inverse and direct variation. Alright, some statements of variation, and I'm reading out of the book here, some statements of variation give the relationship between two or more variables. So sometimes we're going to have more than just two variables. The word varies jointly imply a sort of double direct variation that is only one constant of proportionality. Thus the statement that peaches vary directly as apples and raisins implies the following relationship. Peaches varies directly as apples and raisins. So it's a direct again, so the k is multiplied, but since there's two of them, we're going to say it varies jointly. Okay? So let's go ahead and, well, let's just keep going. If they were to vary inversely, then it would be P equals, and you can probably guess, A R, because it's inversely, so what it's being compared to are on the bottom. Now if we're using the ratios, we have this, just real quick, apples, raisins, and then if we're using the inverse, we're going to have again peaches equals, and these are just going to be switched over. Okay, that's the only difference there as far as what we're doing. Okay, so let's go ahead, and it says at the top of page 399, I suppose I better cover that before we jump into anything. It says in some relationships we have both direct and inverse variations in the same statement. So the statement that girls vary inversely as boys and directly as teachers. So we have the direct as teachers and the inverse as boys there. So we can do both of those in the same one. Alright, so either one works. So let's look at example 96.1. The number of girls varied inversely, so let's go ahead and write our equation. Varies inversely as the number of boys and directly as the number of teachers. Okay, so I've got my equation there. When there were 50 girls, remember we find k first, when there were 50 girls, there were 20 teachers and 10 boys. Okay, that helps us to find k is 25. So now we can continue reading it, and our problem now looks like this, because we have a k now. Okay, now we're going to look and see what else we have. How many boys were there? How many boys were there when there were, oh, that's bad English, 10 girls and 100 teachers? So we're looking for boys. Alright, so there you go. So you should get 250 boys when you're done. Okay. Now you could also use the formula G1, G2 equals T1, B2 over T2, B1. Okay, very similar to the very top of page 399 with the formula. Then you're not looking for K at all. You're just putting in all of the numbers in order to solve this. So instead of solving for K, you're going to end up going, okay, we started with 50 girls, and now we're looking at 10, and then we've got 20, and we're looking at the boys, and we have 100, but we started out with 10 boys, so the final boys is what we're looking for, and you do the math there, and you also find it to be 250. So let's look at 96.2. Strawberries varied jointly as plums and tomatoes. Strawberries varied jointly as plums and meters. Alright, if 500 strawberries, I know I'm going to be looking for K, went with 4 plums and 25 meters. Okay, so let's find K. So that's going to be 5 equals K. Is that right? 4 times 25, and we end up with K is 5. Okay, so then it says, how many plums would go with 40 strawberries? There's our K. We're looking for plums, and they should tell us tomatoes. 2 tomatoes. Alright, so they give us that, and you find out, let's see, 10, 44 is how many plums you have. Okay, and again, you can use the S1 over S2 equals P1T1, P2T2. And then that would give us S1 was 500, that was our initial strawberries. Our final strawberries was 40. Our initial plums, our initial tomatoes, and our final plums is what we're looking for, and our final tomatoes was 2. And you end up looking for this then, and you also, again, get 4. Alright, so that is what's going on when it comes to joint variation. So let's jump to more on irrational roots. Alright, so we found out in lesson 8 and 95 that we could take something like 6x minus y equals 5. Whoops. And then we had what? xy equals 4. This was at the beginning of the lesson. We had that. And we used substitution in order to find out what our answer was. And we ended up with a quadratic equation, if you look back in your notes, that looked like this. And we went ahead and solved. Okay? This equation can be factored, and thus the solution to this system consists of ordered pairs of rational numbers, which we ended up with fractions. If a quadratic equation cannot be solved by factoring, and this is really important, if you look at this and you find out that it cannot be solved by factoring, we can always find the solution by using the quadratic formula. Trying the factor method to solve quadratic equations that result from real-life problems is usually a waste of time. Real life is not nice and neat, and you can just look at this and go, oh, this isn't going to be any problem. I can just go ahead and solve it this way. That's not how life is. Life usually gives you decimals and radicals and imaginary numbers and all that junk. So, I would suggest not even trying this on these problems, because chances are very slim that you're going to actually be able to factor these problems real easily. I would just jump right in to the quadratic formula. So when we do these, you're going to end up with something like this, and you're going to be like, okay, well, I know I can't use elimination because this has a minus between the x and y and this doesn't. So my only option then is to use substitution. So I'll make this x equals 6 over y, and then plug that in there. Okay, multiply the whole thing by y, and I get 6 minus 2y squared equals 3y. And let's go ahead and flip everything around, get everything on the left side of the equation, change all of my signs so that my 2y squared is a positive, and I get that. Alright, so again, I took this equation right there that's jiggling around, and I turned it into this equation here. Okay, so what that tells me then is I use my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a in order to solve that. Alright, so let's say that you are just really wicked smart and you can solve this by yourself. What we end up with is y equals, because remember we solved for y, this was x equals 6 over y, and then we went ahead and so we're solving for y because that's what we have here. And we found out y is negative 3/4 plus or minus square root of 57 over 4. A fun answer for y. Now, this is where it gets a little bit rough, because that is our y value. We have to find our x value. So that means we have to take this, plug it in here in order to find our x. Okay? So we've got that equation. I'm going to put it down here because I'm going to slide that stuff up there, up, out of our way. Okay, so we have room. Alright, so we're going to plug that stuff in to this equation. So we have x equals, let's move all this over, so x equals 2 times negative 3/4 plus or minus the square root of 57 over 4 plus 3. Doesn't that look like a good time there? Okay, well, let's go ahead and try this. So I'm going to have to make two columns because I'm going to have two answers here because of this plus or minus. So x equals 2 times negative 3/4 plus the square root of 57 over 4 plus 3. And x equals 2 times negative 3/4 minus the square root of 57 over 4 plus 3. Okay, so I'm going to get two answers here. Doesn't that sound like fun? Okay, let's get this out of here and move that up. Alright, so as we solve this, we get x equals negative 6/4 plus 2 square root of 57 over 4 plus 3. So x equals negative 3/2 plus square root of 57 over 2 plus 3. So we're going to take that and add those. And we'll get a positive 3/2 plus a square root of 57 over 2. So that's my x value when my y value is that. So I have 3/2 plus the square root of 57 over 2. There's my x value. And my y value is that. So there's my x and my y value. Now I do the same thing over here. Multiply this through, and I'll get an x value, and I'll use this as my y value.